Up everybody, welcome to question 9 in November 2020. It was a cubic function that is given by g of x, and then they draw the graph for us, and then they give us two turning points where the graph is turning, and then the questions below that is question 8.1 up until 8.5. We are going to deal with these questions. Let's go ahead and deal with question 8.1 up until 8.3. Make sure that you subscribe if you haven't subscribed. This will also help and assist the channel to grow and also give more content when it comes to mathematics. I am Gaston Mapala, your one and only, right here at Maths with Gaston. Right. Okay, now let's have a look at this question. So the graph of g of x is given by ax cubed plus bx squared plus cx. It's a cubic function. Okay, we'll get that. And then the y-intercept, they're giving us the y-intercept is there at 0 is to 0, is drawn below the x coordinates. They're giving us the x coordinates here of the turning point given by that. So we don't know the y there. And also here, there's a 2, but we don't know the y value of the turning point. All right, great stuff. And then we understand that this is the other x-intercept there. There's 3 of them. Right. Okay, now the first question says, for which values of x will g increase? For which values of x will g increase? So basically, starting from here, can you see? Starting from here. If you start from here, you are going down. Okay, so if you start from here, going there, what is happening to the graph? It's going up. Therefore, the function is what? It's increasing. All right, it's increasing. It has got a positive gradient. All right, so going up here, it's increasing. Going down here, it's decreasing. It's got a negative gradient. Even this side is got a negative gradient. Please don't forget your basics of analytical geometry, guys, because you will find this very, very difficult or struggle with them if you have to deal with it. Okay, so now I would say starting from here, going that side, the function is increasing. Therefore, starting from this x value, also going backwards, okay, the function is also increasing. Therefore, we're going to say x greater than -1 and x less than 2. Voila. No need to stress about it. No need to overthink. It's just 2 marks, 1 mark for each. And that's how you deal with 8.1. Okay, 8.2, it's saying write down the x coordinate of the point of inflection. Okay, point of inflection, remember, point of inflection, we get it when the second derivative is equals to 0. Okay, so in this case, you won't be able to do that because now you're not given the equation. But, okay, let me just put it here because I need to give you guys some tips on this one. But the x value of the point of inflection, of this point of inflection, but how do you get it if you are given the turning point? Okay, we can say this value lies somewhere here. It's in between the two turning points. So therefore, mathematically, point of inflection, right here, point of inflection is between the two. Please write this down, guys. Is between the two turning points. Okay, is between the two turning points. So what do? You just need to take the average of the two. Okay, so the point of inflection, let me see, inflection is going to be equals to the x value of the turning point number 1 plus the x value of the turning point number 2 divided by 2. Okay, so what is the x value of the turning point number 1? It is -1, and then that one of number 2 is +2 all over 2. Therefore, this point of inflection will be given by half. Okay, and that's how you would deal with this one, guys. Please always, if you're given a cubic function, then they require you to find the point of inflection. When they've given you only turning points, you just have to add the two of them and then divide by 2, because the point of inflection is somewhere in between here. But however, if you are given the equation and they want you to find the point of inflection, you know what to do. The point of inflection, let me just add the notes here. Inflection You find it when the second derivative is equal to 0. Therefore, you go and find the x value and then also find the y value thereof. All right. And that's how you would deal with the point of inflection. Always remember the concept that has to do with each and every one of these things. Okay. So let's come here. 8.3. 8.3, for which values of x will g be concave down? Okay. I know, guys, whenever you hear concave down, up, but I can tell you, in case you forget, this is for the first time where I'm going to actually say cram this. In case you forget, if they ask you for a point of inflection, okay, and then a is positive for that cubic function, what you can do right there and then, there is no need to waste time. Anything, anyhow, you just say x greater than that point of inflection, x greater than the point of inflection, which is half. Okay, so at this point of inflection, anything greater than this point of inflection, I think half is somewhere there. I mean, it does make sense. I mean, anything from there, from here, the graph is concave up, is going up again. Okay, so it means this point here, that is half, the graph is concaved up. Okay, which actually makes sense if you look at the sketch there, guys. All right, so there's no need to panic. Just know that concave up, if a is positive, therefore you just have to say greater than the point of inflection. All right, so let's go ahead, do 8.4 and then 8.5. All right, I just moved the sketch to this side so that we can also continue to deal with it. And then 8.4 is saying if g of x, okay, we know this is the first derivative, which is the gradient for this function, determine the equation of g. Okay, interesting, very nice question. I like questions like this. Okay, 8.4. I'm just going to be slow a little bit for you guys to understand and grasp this concept right here. Okay, what are they saying? They are saying if this is the gradient, if this is what they gave to you, okay, when you go to varsity, guys, you'll be learning how to reverse a derivative. There's a part called integration. Okay, so they don't teach that in high school and secondary school, so but you can integrate and go backwards to the original equation. But in this case, it's fine, we don't know that, but we're going to use what we have. So this is what they've given to us. This is what they've given to us. Okay, so now what we need to do now, we need to take, this is the general formula that was given to us, a x cubed plus bx squared plus cx. All right, so therefore let's take the derivative of this one. Okay, I think I should have used a different color. Okay, this is g. I'm gonna call this g so that it can be g given, because they look the same anyway. Okay, so this one, let's take the derivative of this one. Here, 3 comes down, 3a, and therefore x squared minus 1 plus 2ab. Therefore, you say x. Okay, therefore the derivative there plus c. Okay, so therefore once you are here, it's g of x and g of x. Okay, so g of x from the general formula is equals to the g of x from the one that is given. Okay, so now what we can do now, we can, because they are equal, we can equate them term by term, or rather we can equate both equations, right? So from what I have done from my side, I prefer doing it like this, guys, because it's already here. This is term 1, this is number 1. Let me just okay, let's do this, guys. Let me do this. That should be equal to this. Okay, can you see? Okay, so let's do it here. Oh, no, I'm actually mistaken, not that and that. Okay, the derivative, not the general formula. Okay, so the derivative, the derivative given equation should be equal to that of the general formula. Okay, so now it's going to be minus 6x squared should be equals to 3ax squared. Okay, So therefore, we're looking for what? We're looking for a, divide both sides by 3x squared all over 3x squared. 3x and this x squared will cancel out. A is going to be equal to this x squared, the s squared is gone. Negative 6 divided by 3 is going to be negative 2. Great stuff. Okay, so now, okay, let's move on to the second term here. Now the second term will be 6x and then b squared here. All right, so 6x is equal to 6x is equal to, remember we're looking for the general equation here. It's equals to oh guys, oh my goodness. All right, not that, I keep circling the general formula, sorry about that. Is equal to this here. Okay, so it's going to be 6x is going to be equal to, let me just fix this one here, 2bx. All right, so divided by 2x both sides, divided by 2x, x and x will cancel out, 2 and 2 is gone, x and x is gone this side, b is therefore 3. Okay, great stuff. So now also on this side now as well, we're left with one term as it is now. We're left with one term. We're left with one term. So it's going to be 12 should be equals to c. All right. So in this instant, c is going to be equal to 12. And therefore, the general equation would therefore be, once you have done completing that to find the value of x of a, b, c, therefore our general equation would therefore let me just see something here, guys. Looks like I'm making a terrible mistake here. Okay, our general equation will therefore have to be, oh, okay, yeah, all right guys, therefore you can substitute this here and you have g of x is equals to negative 2x cubed plus 3x squared plus 12x. Okay, and that's how you will deal with this question of 8.4. All right, so now let's move on. Let's move to question 8.5. All right, 8.5 said determine the equation of a tangent to G that has maximum gradient. Write your answer in terms of y mx plus c. Okay, so immediately when you hear them, when you hear these words, maximum gradient, okay, please guys don't panic. When you hear maximum gradient, just think of first derivative. Okay, just always think of first derivative. First derivative of a function, it gives us the gradient. So now when you hear that word, think of the gradient. Okay, so we already know the first derivative, and then also we also know the point of inflation. Okay, so the tangent will take place at the point of inflation. All right, so now we know that x at the point of inflation was half. Okay, and we know that g of x, which is the derivative, it was given to us by negative 6x squared plus 6x plus 12. Okay, great stuff. So now we need to come here and say, okay, the gradient, what is the gradient at this point of inflation? Okay, minus, we need to be 0.5 squared plus 6, 0.5 plus 12. Okay, plus 12. And then what you need to do here as well, put this in your calculator. Let me just quickly press this, my calculator. It is giving me 27 over 2. Okay, therefore once you have this is the gradient at this point. Okay, this gives you the gradient at this point. Okay, so now What you need to do here as well, you need to find now, we have got the gradient. Remember, we got the gradient, so we need to find the x and the y so that we are able to get c. Okay, so we already have the x, which is half. So what will be the y? So we need to substitute back into the original equation in order for us to find y. So we know that the original equation is given by g of x. We just calculated it now at 8.4 is equals to minus 2 x cubed plus 3 x squared plus 12 rather x. Okay, so we do just need to find the y value when x is equals to half. We're gonna substitute everything into our original equation. Plus 3x is equals to half squared plus 12 half. Okay, which all in all is going to give us, if we were to put this into our calculator, is going to give us 13.2. Great stuff. So now we got 13.2. Now we can come here and find the equation of our straight line. We've got the gradient, we've got our x value, we also got our y value here, which is our y. So therefore, the equation I would like to use is y is equal to y1 is equal to the gradient x minus x1. Therefore, we need to substitute here. Y is 13 over 2, gradient is 27 over 2 x, and therefore x1 is half. Okay, so if you were to substitute this into your calculator, I'm not going to do the algebra here, guys, but if you were to put this into your calculator, you should be able to reach an equation of y is equals to the gradient. Because you guys are in metric, I'm gonna leave the algebra for you guys to sort out. You can pause this video and then write the answer for yourself and just double check if you managed to get it right. Okay, but this is what I got. 27 over 2 x minus 1 over 2. Okay, and that's how you would deal with a question like this one, guys. I am Gaston Mapala, right here at Maths with Gaston, still continuing with paper 1 past papers. It's a series, guys. Please make sure that you subscribe. We are uploading these videos every single day so that you don't get lost, and then sooner than later we'll be starting with paper 2. I would like to send a shout out to all my viewers right there in Cape Town. Shout out to you guys. Thank you. I really appreciate you guys supporting my channel and subscribing and also viewing my videos, and I hope that this really assisting you. All the best with your exams. See you on the next upload.